In all our discussions of memory, we've only spoken about memory which is allocated and defined prior to executing the kernel call. Now, what about memory that's being allocated while the kernel is being executed? Well, we already know that this is possible because that's the way that we define the TID for so many kernels. So memory can in fact be allocated right within the kernel. And it has, for obvious reasons, thread scope, meaning that something that's allocated in one thread is inaccessible to a different thread. And it also has kernel lifetime, which means that once the kernel is done, that memory is gone as well. Now, there are two different scenarios for the type of memory that can be allocated and the things that happen to it. So if you allocate something that's not an array, like for example, we allocate the TID variable, then this is stored in a register and it's very fast and there is no problem with it. However, when you allocate something that's an array, then it's stored in this hypothetical construct called local memory. And now local memory is by itself an abstraction. So things actually get put into global memory or device memory, as we've been calling it. And as a result, this is slow. So the local memory doesn't exist by itself. It's simply a kind of way of saying that even though we're putting something in global memory, it's not in any way becoming accessible to other threads. So that's something to consider when you allocate memory right in the kernel.